Hello, everybody. I'm Brandy from Krannich Solar. Thank you for joining our webinar today. And we're welcoming Yotta Energy. Before we get started, though, I do want to give a quick presentation about Krannich. So here we go. Krannich Solar is headquartered in Germany and was founded by Kurt Krannich. Since being founded, Krannich has expanded into 23 different countries with the capability to ship over to 100 countries. Krannich Solar has been a strong partner to PV installers since 1995 and offers everything that is required to begin and finish your solar installations. Our international purchasing power has helped us build strong relationships with your favorite manufacturers, such as Yotta Energy, to secure best pricing and availability. With a growing market share, Krannich Solar is privately owned and self-financed company that ranks among the leading solar wholesalers worldwide. Our experience in delivering solar products worldwide for the last 26 years has made us experts in our field. In 2005, Krannich expanded into the US with a US headquarters in New Jersey. We also have branches in California, Florida, and we are expanding into Texas with additional warehouses across the nation. We are growing every day, so keep an eye out where we might be next. Our US team consists of over 80 employees that service the Americas and strive to offer the best services and options to our partners. Throughout the years, we have grown our product portfolio to provide 5,000 products. We have partnered with leading manufacturers worldwide to offer the best material for a project of any size, whether it's an off-grid system, 4-panel shingled roof, or megawatt flat roof. Working with Krannich Solar means you'll never work alone. With our streamlined ordering process, each customer at Krannich receives a dedicated sales rep to walk them through each step of the ordering process, from project design or on-site delivery. The solar industry is always innovating and changing. At Krannich, we do our best to make sure you know about the latest products and technologies available. We team up with industry leaders and seasoned professionals to train you firsthand on everything you need to know. It will always be free for you. And this concludes my portion of this webinar. Here's our contact information if you would like to reach out for a quote or if you have any questions regarding the products or services that we offer. If you have any questions throughout the presentation, please feel free to answer or ask them using the question box, and we will answer them at the end of the presentation. And thanks again for joining us today. And now I'll pass it along to Yotta Energy.
Good morning, or good afternoon, everybody, actually. I hope you can see my screen. Let me see, I got all three of them right there. Hold on one second. There we go. Sorry about the little technical difficulty there, but anyways, long story short, we are here. Thank you so much for attending. Hey, my name is Chris Barrett. I am the Senior Applications Engineer for Yotta Energy. Thank you for taking time out of your day today to spend a little time with us to learn more about our products and services. Today, we're going to specifically talk about the Commercial Three-Phase Microinverter, what we call the DPI, including the solar storage or energy storage called the SolarLEAF. The agenda today is pretty simple. We're going to talk about the Yotta ecosystem, what that means, what the kind of products that we're bringing to the market today. Specifically, like I said, dig into the SolarLEAF, our storage solution, on-roof storage solution. Number three would be why the SolarLEAF? Why would you want to use this particular product in a commercial environment? How do we do it? How do we use that SolarLEAF on the roof? Talk about a case study for the SolarLEAF. Then we're going to jump into the microinverter. We're going to go into the three-phase DPI microinverter. I'm going to have a section for specification sheets, so have your phones ready. You're going to be able to scan a QR code on the screen to get the specification sheets, or we can actually send them out after this presentation as well. We'll talk a little bit about the online monitoring. I think this is actually kind of an important piece of the puzzle as well, to be able to see your sites remotely. Then talk about the installation of both the SolarLEAF and the DPI microinverter. We'll have a quick review, talk about some of our partnership services that we offer. As we mentioned, we'll also have questions at the end. So please feel free to put those in the questions box as we're talking today. So those of you who are not familiar with Yotta Energy is a company founded in March of 2017. We're headquartered in Austin, Texas, and currently have 40 plus employees. I think we're actually at 42 now since this slide was put together. Growing like crazy, so having a good time and really looking forward to showing you more about our products. Really, what is Yotta's mantra? Mantra is basically, we're trying to simplify storage. We're going to think of a way to actually distribute that storage, those batteries, instead of having a centralized location for batteries, we're going to put them distributed throughout the roof. And basically, I like the way I say it is, we're trying to take the lessons learned from microinverters and apply those to battery technologies. I've been in the industry now for almost 15 years. 15 years ago, if you talked about a microinverter, you kind of got laughed out of the room. Today, microinverters are kind of a mainstay and have proven their worth very well. So like I said, we've taken the lessons learned from the microinverter world, applied it to batteries, and we'll talk more about that as we get deeper into the presentation. One of the funniest questions that we get asked is, how do you say Yotta? And right here, a lot of people call us Yotta, which is, I can see how that could possibly happen, but the company name is Yotta Energy, not Yotta. And to keep playing on that Star Wars theme, Yotta Energy, see basically the word Yotta is an SI unit of measurement for 10 to the 24th power. And to put it in perspective, this gives you an idea as far as how this all works. I think we're all familiar with the kilo, we're all familiar with the mega, the giga, the tera, but actually those are like to do. It's 10 to the 3, 10 to the 6, 10 to the 9, 10 to the 12. We're jumping all the way down here to 10 to the 24th, or 1 septillion. So if anybody asks you how to pronounce Yotta, now you know, and you know what it actually means. So let's talk more about the Yotta ecosystem and what we bring to the market today. Today, we're going to specifically talk about the microinverter and the DPI microinverter and the SolarLEAF battery storage. So right here. So this is the SolarLEAF, this is the DPI. We also offer solar modules and car chargers as well, but like I said, today we will focus on these devices here in the presentation, as well as the online monitoring portal as well. What does it mean to be energy storage ready? As we mentioned, we're using the microinverter here to convert from DC to AC. And the reason we call it a DPI is because it's a dual power input inverter. This inverter gives us the ability to take inputs from solar modules, which you see here, and the solar storage, which is we call the SolarLEAF. This microinverter itself has 4 independent ports to take in 4 modules. If we go to the next slide, we're demonstrating here the modules then go into the SolarLEAF, which then go into the microinverter. So that you can actually have a complement of module to battery ratio of 100%, or depending on your use case, depending on your needs, maybe you don't need that much storage, you can actually do this as well, have a module into a SolarLEAF, into a DPI, or a module directly into the DPI. Hence, again, talking more about the DPI or the dual power input. The inverter itself has custom firmware to be able to understand or read or sense if it's a battery or a module connected to it. Some of our partners that we work with, proud to say that we work with Tailsun. Tailsun right here is actually a producer of our own module. The big difference between our module is we have longer DC leads. As many of you know, especially installers out there, a lot of the modules have switched to these shorter leads, especially in these split cell modules. To getting those leads into the microinverter becomes very challenging. So we work very closely with Tailsun to produce a custom module for us, which has 2.5 meter whips or DC leads, plus or minus, to be able to successfully get into either the battery or the microinverter itself. Our partner for the SolarLEAF manufacturing is Flextronics. They really are their top tier manufacturer for us, and that comes directly from them. Our microinverter partner is AP Systems. They're the ones that produce this particular product with the custom firmware to work directly with both the module and the SolarLEAF. So let's talk about the SolarLEAF. Yotta Energy's revolutionary approach right here, as it says, the world's first truly integrated solar plus storage solution. Simplified installation and maintenance, because we're talking about something that's very, very small. We're looking at about 53 pounds on the roof. Flexibility, as we just demonstrated earlier, you can use a SolarLEAF under every single module or every other module or whatever you need to satisfy your storage needs. As we say, the architecture grows on demand. So if you need to make changes in the future, you can add storage as needed. The only limitation you currently have is the number of modules on the roof. I need one module to charge one SolarLEAF to go into one port on the microinverter. We also believe this is true as well. The highest safety in application. We try to distribute the energy, have smaller amounts of energy scattered throughout the roof instead of having everything in a centralized location, either inside of a building or outside on a concrete pad. And we'd also believe it's the lowest system cost, because you'll see this in the next couple of slides here and how we can make that claim. I'll pause here for a moment. This just gives you an idea as far as the SolarLEAF itself, size-wise. See, we have mounting brackets here for any kind of ground mount situation. DC leads, this is the DC input, this is the DC output. And then back here is the cooling fins. This particular slide, I'll let this play through a couple times, but I think it's really nice to be able to see how the panel level storage is actually utilized and how it's installed. What we're demonstrating here is panel claw racking. The panel claw racking you see right here, the inverter is being placed into a rack, being put down and tightened in and grounded. The SolarLEAF actually acts as a ballast block. So it's a ballast block replacement for 2 ballast blocks, with the weight being 53 pounds. And simply, both the inverter and the SolarLEAF live underneath the module, so protected from the elements. Some of the key specifications for the SolarLEAF was solar input. Right here is up to 750 watts per solar module. That includes the 60 and 72 cell modules, but it also includes the 120 and the 144 split cell modules as well as bifacial modules as well. The one thing that I really care about is the most important is 60 volts and 12.5 amps is the highest input from any one of those modules. That is the key measurement for all. So again, 60, 72, 120, 144, and bifacial. Compatibility, as I mentioned, the Yotta DPI microinverter works hand in hand with the SolarLEAF. The battery today is a 1 kilowatt-hour battery, and we use the chemistry called lithium iron phosphate, or LiFePO, the safest battery chemistry out there today. Life cycle, looking at about 6,000 cycles, which is about almost 18 years of cycling every single day. On the mechanical side, as I mentioned, 53 pounds, so it is quite light, and it's a one-person lift, so that's really convenient. As far as the weight on the roof, we're looking at 2.7 to 3 pounds, depending on what racking is used. As I mentioned, a couple different mounting options, PV racking, and we can actually connect to that directly through the ballasting, sitting in a ballast tray. Operating temperatures, actually quite wide range. So -20 C all the way up to 65 C. And dimensionally, if you can just picture a small carry-on, a small suitcase perhaps, that's what you're looking at for size-wise. So installation is a breeze. For getting this to the roof, one person lift, one person drop right in place. As I mentioned, we work directly with PanelClaw as one of our preferred vendors for the racking. And what nice thing is about his racking is PanelClaw will actually be able to provide a drawing for their system, be able to provide the information as far as the racking and the blocks where they need to go. This is an example of a map that they would provide in their drawing package that would demonstrate where SolarLEAF would go. The 2s means there's 2 ballast blocks. The 1s mean there's a single ballast block. Anywhere there's a 2, we can put a SolarLEAF to hold down the weight of that device. Not saying you could put a SolarLEAF in a 1, but it's not necessary. Again, the biggest limitation for you is the number of modules you have. It will dictate the number of SolarLEAFs that can be used on that particular roof. The next slide right here just gives you a picture or a visual of what this actually looks like in a real situation on a roof. This particular roof is TPO. You can see the PanelClaw here, PanelClaw racking sitting on the roof. You can see the ballast block along with the SolarLEAF. The DC inputs are not plugged in yet, but we're going to basically drop the module in front here. The inverter is going to sit here and make all the connections straight through. So I guess the obvious question now is why? Why use the SolarLEAF? Let me tell you. One of the biggest things right here is what I like to call the hidden cost. This iceberg slide, I think, it really articulates what we're trying to do here pretty well. I have a few slides to talk about this. But think about it up front. The upfront cost is equipment cost. This is for your traditional ESS. This over here is for your Yotta solution. We believe that having a traditional EAS, there's that water line, if you will, right there. Above the water line is what you see. Below the water line is what you don't see or what you don't think about. For a distributed energy solution, we have very little engineering and design. We have no need for fire suppression. Independent metering, it's all done inside the battery. We don't require any kind of foundation or concrete padding. We don't require any kind of separate permitting because we are located on the DC side, not the AC side. Tailored installation, real estate, thermal management is a big one as well. How do we keep batteries within a certain range to run at optimal performance? The other one is heavy lifting machinery. So we're talking about 53 pounds, easily a one-person lift per battery storage, as opposed to a larger system, which may have to get craned in or forklift in. This is where we see the big advantage on the Yotta side, to being able to have the system on the roof, easily accessible, without having all these other below the water costs. This next couple slides actually shows us a little bit better as well. Talk about some of the, this one where we're even par up to this point. But then you start adding in all the other costs that we mentioned, all below the water line. So you can see a significant difference in pricing for your storage solution from a centralized system to a decentralized DC coupled system. Another big advantage of being on the DC side is one of the biggest issues that I've experienced in this industry for a lot of years now is what we call clipping. A lot of people have a big problem with clipping. I'm kind of in the mindset of clipping is good as long as you're not clipping all day long. I want to make sure that you push the inverter as hard as you can for as long as you can. We know modules degrade over time, and as they degrade, that clipping point will drop and drop and drop until it's below the line of the maximum output of the inverter, and then you will not be capturing as much as you possibly can. For those people that are concerned, the nice thing about having the SolarLEAF in line from the module to the inverter, you're actually able to capture that. We can actually use larger modules now on inverters that may not have, but like I said, the inverter itself has a 450 watt AC output per channel. You can put up to a 750 watt panel onto the SolarLEAF. That extra energy goes into the SolarLEAF. In the SolarLEAF itself, we have a battery management system, which is monitoring the inputs and the outputs. So the inputs from the module and the outputs to the inverter. So we're able to simultaneously charge and discharge to maximize output for the system and for that site. This right here is the solar plus storage value chart. And I think right here, this is a key piece and the key markets in which Yotta Energy is actually trying to attack. These three things are the things that we can do and do well today. Demand charge reduction. We're actually able to go in and monitor the consumption of that building. And as many of you know, demand charges can be very costly. And they can only happen, they only need to happen for a short period of time. And then the rest of your bill is based on that peak demand. We're actually able to monitor that and then discharge very quickly to meet the demands of that demand spike. Time of use bill management. We can also set it up in such a way, I know many of our customers in California, for example, and I'm sure it's coming across the country, they have time of use pricing. So let's just make up numbers. So California, let's say it's 25 cents a kilowatt hour. During that time of use, let's say it doubles and goes to 50 cents an hour. The nice thing about the time of use management on the SolarLEAF, you're actually able to discharge at any given time. Let's say your time of use starts at 4 p.m. You can charge your batteries all throughout the morning with your solar. And in the afternoon, let's say 4 p.m., you can say, I want to discharge at 4 p.m. this amount for this amount of time. That's all can be pre-programmed into your system, and it can be changed easily via either the online web or the handheld application. The third piece of the pie that we actually are enjoying as well is energy arbitrage. And then this is coming across the country as well. This is a situation where customers or companies, utilities actually, may need more power and they want to have power available to them. They can reach into your system and discharge the batteries at their whim. The nice thing about this is you have storage available and you also get paid for that discharge. And they usually pay a premium to get that power when they want it. So our system is able to do that as well. So it all boils down to, well, how does Yotta do this? I mean, we're talking about having a battery sitting on a roof. We know it's a fairly harsh environment, both hot and cold. The big thing is here, and this is what I was mentioning before. Thermal management is the key to success in any kind of battery situation. One thing that Yotta Energy has done and done well is thermal management. And honestly, that is one of our big things. And we have patents, 6 patents today about thermal management for batteries. And what we've done is we've basically 4 different things that we've done to mitigate heat inside the battery chamber. The battery itself, battery box, actually is a die-cast aluminum box surrounded by, number 1 right here, is a vacuum packed ceramic board. This actually wraps around all 6 sides of the battery packs. That provides the thermal insulation, if you will, from the outside and then from the inside as well. I'll tell you about that in a second. So basically what we're doing is just think of it like almost like a thermos, if you will. You pour coffee in the thermos in the morning before you go to work. You open up the thermos at 11 o'clock in the morning, that coffee is still hot. Vacuum is a very poor conductor of heat. So it gives us basically a thermal blanket around the battery cells. Number 2, here, we also have what's called a phase change material. So inside of here, there's actually basically a paraffin wax around the battery cells. Those battery cells, when are heated, will feel or see that that material, the phase change material. That phase change material will go from a solid to a liquid. And in the process of doing that, we're able to draw a lot of heat away from the batteries, trying to maintain that perfect temperature. Number 3, in the process of removing that heat that is generated inside of here, we also have thermal pipes underneath the device that are pulling all the heat out to the heat sink on the back side of the device. All of this is passive. All this just happens automatically. There is no moving parts. Everything just happens without any kind of use of fans, anything. So that's nice, right? So the nice thing is, as you see down here, what we're trying to do is put the batteries in a range for success. And our range for success today is between 70 degrees F up to 100 degrees F. This is the band which the batteries love to live in. They will operate well, and the reliability is super important. So next logical question is, let's say I live up north and it's cold, and I want to maintain that between 70 and 100 degrees F. Yotta Energy has also thought of that, and in between the battery packs, we've installed thin film heaters to be able to warm the situation. This will warm the batteries up should there be a situation where the temperature drops. Another important thing is fire safety. It's always important to talk about it because I think it's a really important piece of the puzzle. Fire safety by design. Low voltage system, right? We know right now we're under 80 volts. According to NEC, anything under 80 volts is what's considered touch safe and eliminates any kind of risk for arc faulting. That is really a key piece right here. So the voltage that you're going to have on that roof is the highest voltage you're going to be from your module, which modules today are probably somewhere in the 40 to 45 volt range. Same with the battery. The battery's going to come out at like 38 volts. So again, all under that 80 volt risk. LFP technology, they're basically chemistry. This right here is, again, safest battery technology out there today. We've actually gone through the UL 9540A testing. And again, as I say, no external flaming at all. Everything was inside or kept inside of the device. No issues. We talked about the layer of ceramic insulation. This right here is basically your heat blanket to keep heat in or out, but it also acts as a fire blanket. If there's any kind of thermal runaway at all, this fire blanket will actually distribute that and take care of that issue. The other nice thing is, because it's a distributed design, we know that each battery is a minimum of 3 feet away from each other. Again, minimizing any risk of any kind of issue on a roof. Microinverter meets all the requirements for the NEC 690.12 rapid shutdown. So rapid shutdown of the device and also module level shutdown as well. And as I mentioned, this battery management system, or the BMS, is built right directly into the SolarLEAF. So here's the case where don't believe us, believe them. Take a look at what we've done here. We had a situation at a test site, basically at CSUDH, Dominguez Hills in California, just south of Los Angeles. And this was a situation where I was out there with a test site. This was a day in summer, Los Angeles. I think it was a couple of years ago now, that they had an ambient temperature of almost 140 degrees on the roof outside. I think the ambient temperature was somewhere in the 125 or 128 range. But under the module, we were able to measure 140 degrees there. But you see the green line here. We were able to maintain that temperature under 100 degrees, as I mentioned. And during all that time, temperature rose, inside rose as well, but we were able to remove and mitigate that heat and get it out. To make sure that those batteries stayed in that performance range, that optimal range of between 100F and 70F. This slide right here just again demonstrates this SolarLEAF performance on 2 different dates. This is 2020, June 2020 and September 2020. I put this up here on the screen here. You can actually download the case study here. If you have your phones, you can scan that QR code. It'll take you directly to it, and you'll be able to download everything you'd like and be able to see the whole entire white paper that was written. But what we're trying to show here is, you can see in the morning, when the morning comes up, you can see the solar production and then the waning of that sun. What was nice about it is in the morning, you can also see the storage. This right here, this green is the SolarLEAF absorbing all of that power. The afternoon is when the SolarLEAF discharge. This is that time of use I mentioned. So we set it up here to discharge at a certain rate for a certain amount of time and to shut off. Same thing here in September. You can see solar rise and fall. You can also see battery charge and also battery discharge. And again, I encourage you to go to the website, take a look at this entire case study. So next is system configuration. Let's talk about how this is actually set up and how this would actually be used in a real world situation. As we mentioned, this is we call it PV coupled configuration. Again, we start with the solar modules here. And what we're going to talk about first is the 208 three-phase DPI 208. With the DPI 208, it's 1728 AC watts out, which equals 432 watts per channel of AC out. Module compatibility, 600 watts or plus. We can actually do more, but again, it goes back to that interest in clipping. With the 208, we can do up to 5 units on a 10 gauge wire, which would equal 20 solar modules. And as we're trying to show here is we have 1 to 20. And you can see here, in this particular case, we're demonstrating modules into a channel of the inverter, from the inverter or out to the AC line. And all of that, all 5 of these units, 20 modules, all go down to a 30 amp, 3-pole single throw breaker. Again, I was going to mention that. So it's 5 of the DPIs, 4 units, 4 solar modules attached to the DPI, times 5 equals 20 solar modules, 5 DPIs, all going down to a 30 amp, 3-pole single throw breaker. Pretty impressive. Fast forward to 480. Same kind of configuration, but because of the higher voltage, we have lower current. I can do up to 11 units, which equals 44 modules. You can see here, 44 modules. So again, we're doing the same 10 gauge wire from cable. We're doing the same thing with the modules, 4 modules into the inverter itself. The inverter then goes down to the sub panel at 30 amp, 3-pole single throw breaker. Simple solar. That's what we're trying to work with here. The next example here talks about the solar modules and the addition of the SolarLEAF. And as we mentioned before, you can have 1 solar module with 1 SolarLEAF. That's a perfect complement right there, 4 for 4. Or if you go to this example, let's say you don't need that many batteries, that many SolarLEAFs. You can omit some, again, because this is the DPI, the dual power input. You can put power from the module directly into a channel or from a battery directly into a channel. All of which, again, goes back into that 30 amp, 3-pole single throw breaker. The nice thing about this here, like I said, is the DC coupled system. This is on the DC side. Now let's talk about the 3-phase microinverter, the DPI. Let's take a little deeper dive into this particular product. Here is the DPI. As we mentioned, it supports up to 4 high-capacity PV modules. This is what we believe is great for CNI, so flexibility to add storage as needed. Advanced monitoring, Zigbee network, easy installation, and I think the most important one, I'm going to circle it here, a native 3-phase 4-module grid-tied microinverter. And say that again, native 3-phase inverter. What I mean by that is it comes in 208 volt or 480 volt native. So phase monitored, phase balanced right out of the package. You don't have to do any kind of balancing yourself on the site. It's all done within the device. The device itself has 3 lines coming out of it, line 1, line 2, line 3. If there are any issues from the utility or a transformer, let's say you lose a phase, the inverter will be touch safe within 1/10 of a second. So that's a critical piece right there. Very easy to install, no more phase, no more balancing of anything. It's all done within the device itself. So as far as design is concerned, as far as configuration is concerned, let's say you had a roof where you had 480, for example. and you had 11 inverters running direction, 11 inverters running another direction, you could have 3 inverters running a separate direction. It's already phase balanced because the phase balance is within the inverter, not the wiring. Rapid shutdown compliance on both inverters, the 208 and the 480, built in from the start. Heat dissipation, again, that's been proven technology now for a long time. Remote diagnostics, we'll talk more about that as we get into the presentation, as far as the remote monitoring as well. As far as the codes and standards are concerned, we currently meet all the standards for the NEC 2023. And I know many states have not even adopted that yet, but the nice thing is we meet the requirements, especially Article 690, again, that's 690.12, and for 706 for energy storage. Also, for energy storage systems, the ESS, the 9540, which is the umbrella for UL 1741 and UL 1973. Some of the DPI highlights: 60 and 72, 120 and 144 split cells. Maximum power upward of 1800. That's one thing I want to mention, actually. 1800 for the 480, 1728 for the 208. Module sizes, again, 550 or higher. Zigbee communication. This is a wireless protocol. Quite nice. Broadband speeds. And if you're not familiar with Zigbee, Zigbee is kind of a point-to-peer network, giving you the ability to talk directly from the gateway to the inverter, but also be able to have a peer-to-peer network, being able to talk through each other to get signals back and forth messages. As we mentioned, 690.12, NEMA 6 rated. This right here is basically a submersible. We know on many commercial roofs, it doesn't happen often, but when it does happen, they can be flooded. And if they are flooded, we don't want the products to be damaged. So these are compliant and will they can be submersed underwater and still work fine. And UL 1741 SA compliant today. Anybody that's interested, SB will be coming here at the end of the month. Guess this is a bit redundant, but this is exactly what we talked about. Most important being here, native three-phase product. As far as understanding how this all works together, we know that we have to go to a 30 amp 3-pole breaker. And we also know that NEC will only allow us to put up to 24 amps on a 3 to 30 amp breaker. So you can see right here, out of every single device, we got 4.8, 9.6. We can start adding up as we get to our ultimate of 24 amps. So this is why in the DPI 208, we can have up to 5 of the DPIs, 20 modules. It's just a little bit more review. The nice thing is rapid shutdown compliance. We believe lower costs of energy over time and safe. Again, pairs with many different module types. Encrypted Zigbee communication and monitoring. More power generation per module. Lifespan of 25 plus years. Panel level monitoring. And again, system expansion with ease. Reliability is everything, and safety is also really important. We're talking about very, very low voltage DC on the roof, ACs on the roof as well. But again, to meet that requirement for NEC 690.12, we can be touch safe within 100 milliseconds or 1/10 of a second. We mentioned 4 modules, lowering cost, balance of system, 690.12, rapid shutdown, safe for emergency responders. Some of the cables and accessories that you would be using in this particular situation, AC bus cable, as I mentioned, is a 3 conductor. The drops, meaning drop from point to point, is 4 meters. You can handle up to 30 amps. 3-phase 10 gauge. As we mentioned, 5 units for 208, 11 for 480. This right here is a connector cap. Let's say, for example, you ran this and you needed to skip a drop. This connector cap would go right on here, make it watertight, dust tight. On the end of the line, here's the end cap for this. We'd actually put the wires in here, tighten it down, watertight and dust tight connection. Another question we get, let's say I have an odd number of modules on the roof. I know you got a 4-port inverter and I only need 3. Well, that's okay. We can abandon that. All we need to do is put on a DC cap, both male and female. And last but not least, the disconnect tool. If for whatever reason you need to disconnect a microinverter from a trunk line, this disconnect tool is required by NEC to have a disconnect, means of disconnect, although all you really need is a straight blade screwdriver to be able to disconnect the inverter. The next couple slides are the specification sheets for both the SolarLEAF and for the DPI. I'll pause on here for a second. This is a bit of an eye chart here, but at least if you want to get a copy of it, you can download that now. And then I'll move over to the DPI 208 and 480 specification sheet here in a moment. And this is also available on our website. If you don't have a phone ready available, this can be easily received on our website and also through Krannich as well. All right, here's the DPI 208 480 specification sheet and QR code. Right. Let's talk a little bit about online monitoring. I think this is actually a very, very important topic because it's really important to be able to see what's going on the site, especially for commercial jobs. Being able to see what's going on, if there's any kind of issues, get notified of those issues. So let's dig in a little bit. The nice thing about the Yotta Energy Vision, your Yotta portal, you're actually able to do an analysis of both the modules, the batteries, and the inverters. And you'll be able to see all that. This remote access is available 24 hours a day. Basically, you're going to log in, you're going to have a username and a password to be able to access the site. Your customers will also have a username and password, but your customers will not have the power to do anything. They'll be able to view, where you, the installer, will be able to actually manipulate the system, send commands, do all kinds of things. So communicating in real time. Real time to me is like we call a 5 and 15 minute real time. So the gateway itself goes out and talks to the inverters and to the module and to the SolarLEAFs every 5 minutes and reports back to the system and to the cloud every 15. With this Yotta Vision, you're actually able to see, basically reports. You're looking at the data that's created. You can change the ranges right here, but this just gives you an example of power production of this particular site for the last 30 days. You can take that snapshot, you can see what's going on any given day. And again, like I said, you can go up here, you can change the date range and get different data as you see fit. On the inverter report, this is really one that I like the most. This right here, you're actually able to see the DC power being generated, this curve right here. You're actually able to see the voltage of that module, which is also here. You're also able to see the current, which is that blue line here, rising up and down. This particular site, I've actually shown an example of comparative. So I can compare this is the exact same inverter, 2 different channels, channel 1 and channel 4. I wanted to see how they were tracking. They're tracking, they're next to each other, I want to see how they're doing. This is a great way to be able to see any kind of performance issues on a site. Very easy to see, very easy to sort. Download reports. This is again where we can come in and say, you can say the type of report you want, you can say the date you want, and you can get all the data downloaded here. You can have this in a visual, you can have it in kind of a picture form, PDF and or CSV file. And what we're doing here in Yotta Vision is, this isn't released yet, but this will be soon available to the public. What we're trying to do is trying to be able to put all of it together in a more modern form. We're able to see module performance, battery performance, all the inverter performance, everything that's going on, battery power, solar power, one-stop shop for all of your questions about what's going on your particular site. The gateway itself, very, very simple device. Again, as I mentioned, it's collecting the data and transmitting that data to the cloud. Real-time monitoring. And again, when I say real-time monitoring, I mean the 5 and 15-minute rule. Every 5 minutes, it goes out and reaches out to all the devices, asks questions, things like voltage, temperature, current, power. These are the questions that are being asked. They're being recorded, and then every 15 minutes being pushed up to the cloud. It can be used in a split phase or three-phase environment. It doesn't matter because all the communication is going through the air through the antenna. Built-in Wi-Fi, Ethernet port, and cellular with dongle. Small size Zigbee communication. On the back side of the device, you can see right here, again, this is the Ethernet port for hardwire, the antenna for Zigbee, and then the antenna for Wi-Fi. I threw this slide in here as well. We talked about this a little bit, but I think it's kind of important. Back in the day, we had quite a bit of power line communication. That's kind of been the de facto standard for communication in the solar industry for a long time. And it is a fantastic way to communicate to inverters on the roof. Problem being is the frequencies and any kind of issues that are on that particular job site, especially in commercial. If there's any kind of noise on the line, it makes it very difficult for the gateway to speak to any of the inverters on the roof. This way right here, by changing over to Zigbee communication, we're actually able to go through the air, get better responses, faster responses, because now we're more reliable because we have a broadband speeds. It's over the air where we're not being, we don't have any kind of issues with power line communication issues. We're actually able to use Zigbee, which Zigbee is much like Wi-Fi. Wi-Fi is what we call a point-to-peer network. Point being the Wi-Fi router, the peer being the device. Let's say in our case, it's a computer or a phone or Xbox or Roku box. Zigbee adds the extra element of the peer-to-peer communication. So let's say, for example, I'm trying to talk to inverter number 1, but I can't speak to it for some reason. I know it's there, it's on the roof. I ask inverter number 2, inverter number 2, can you speak to inverter number 1? Yes, I can. They make a connection and they're able to speak, getting that information back to me and being able to get information to the portal to be able to see that remotely. This just gives you an idea as far as the layout is concerned. Again, talked about the modules, plugging into the batteries then plugging into the inverter then going out to the AC combiner box, out to the main service panel, and out to the utility. So again, this is just demonstrating or showing you how simple this particular setup is. Modules to batteries, batteries to inverter, inverter out to the line. As far as the installation is concerned, very simple again. This example that I'm showing you right here, again, is on a panel cloth situation. So we just put this together in the office just to clearly demonstrate how it all works. So this is a single module panel cloth, just to demonstrate. We're actually including this right here is the inverter mounting plate for the inverter we put in. This is actually helping with grounding. So we're grounding this right here together here. Here, the inverter is mounted with screws to make a mechanical bond between these two, electrical bond. And as you see as a finished product here. Now we've got solar ballast block. We also have the SolarLEAF. So we're looking at 1, 2, 3 ballast blocks, if you will. The inverter mounted on the gate. Now we're making the connections here. So out of the output of the SolarLEAF is going into the input of the inverter. And you can see here on the third picture, now we have that input made here, and we also have the AC output onto the trunk line that's laying here on the side. Okay, so in review, like we mentioned, the Yotta module, and it could be any module. Like I said, we sell our own. But we are module agnostic. Like I said, the only thing we do care about is that voltage and current input going into the SolarLEAF, and then that SolarLEAF, the output, going directly into the DPI. Big advantages, we believe, is the lowest cost of installation because it's DC coupled. Easiest to implement. Install with solar PV, accommodate future demands, no additional footprint or permitting because again, it's on the DC side. DC coupled. And safest. We use this lithium ion phosphate, fire safe according to UL 9540A testing, and low voltage system. And again, that rapid shutdown requirement on the inverter itself. As far as Yotta is concerned, as far as partnership services are concerned, these are some of the partnership services we offer. We can help with proposal generations. We can do engineering and plan sets. We can procure equipment as needed. We can also be there to help you as far as installation and construction, financing, and any kind of maintenance going forward. We have a technical support line available. And last but not least, any questions?
All right, so we did have some questions that came through here.
Excellent.
So let's get to those. All right, so I'm going to get to one question just so people know. Someone wasn't able to download the slides. Can they obtain them through the website?
Yes, if you go to yottaenergy.com, all those the spec sheets for the DPI and for the SolarLEAF are readily available, including the modules as well.
All right, and then about some products, somebody was wondering when the 1.5 kilowatt battery would be shipping.
Which size? I'm sorry?
The 1.5.
We don't have a 1.5 today. It's a 1 kilowatt hour only today.
Perfect. And then somebody also asked where they should buy them, direct or distribution, but I would say both potentially.
I would say Krannich would be my answer.
Also, somebody had also asked, so I know you talked a little bit about this, but what is the current status regarding FDNY and the UL 9540A testing?
945A testing is actually complete, and we actually have the documents all available. FDNY, actually, our CEO is actually up there this week, ironically enough, speaking with them and working with them to get that approved.
All right. And okay. And somebody actually asked, is it islanding functionality? Is there any islanding functionality for this?
There's anti-islanding functioning. So yeah, there's not a way to, it is a grid tied inverter. So it has to see grid to be able to produce anything. We abide by the rules of IEEE 1547. Which says that it has to be within a certain voltage range, a certain frequency range, and it has to be idle for 5 minutes after a power outage.
All right, and another big question that I saw quite a bit on here was, can they charge the batteries from the grid?
Today, no. That is actually only a DC coupled system today.
Okay. All right. And another one that I saw on here, besides that, was if the demand charge if demand charge management is being done on site and PV is at full capacity, if a spike comes, can the batteries surge in addition to the PV compensate for the surge?
Yes, because we can use with the BMS system, we're able to actually utilize both the battery and the PV coming in at the same time to meet that demand.
And so another one. Somebody asked, what is the round trip efficiency through the battery?
The round, I guess I don't understand the question.
The round trip efficiency, sorry.
I'll have to answer that offline.
Okay, gotcha.
Get that person's email address and we'll touch base with them after.
Can do. And somebody did ask, what is a typical hold time for contractor support?
Actually, it's pretty quick. We have a team of technical support people here located here in Austin, Texas. The number on your screen here is the 833-MY-YOTA. Give it a shot, give it a call and try it out. We're pretty proud of what we're offering right now. So it's definitely not like some of our other competitors where you're going to be on hold for hours. So I think it'd be more minutes than hours, if anything.
And I think somebody asked, how can Yotta be integrated into a microgrid?
It can be. What we need is some kind of a grid forming inverter and a transfer switch. Something that actually Yotta is actually working on and developing at this point. Because one thing, as you notice from the slide, we work in 3 different arenas. We do not work in the backup power today. Having that grid forming inverter available and having that transfer switch available will change that game. So stay tuned. The nice thing about it, if when we do produce that and bring that out to market, everything you have will be backwards compatible.
All right, and another question that I've seen a couple of people ask was, are the Yotta leaves only compatible with panel claw racking, or because somebody saw a type of ground mount at the end of the presentation?
Yeah, so it's actually compatible with whatever racking you want. Today we have a custom solution with panel claw, so that's why we're talking about that in a relationship with them. If there is a specific racking company that you produce or that you like to use, we would be happy to work with them and create a custom solution.
Okay. And that is pretty much, a lot of the questions were pretty much around the same, very similar.
Great.
And that's pretty much all I have for now, but I will say if you guys have any other questions for us at Krannich or Yotta, please feel free to email us or give us a call.
Fantastic. Well, thank you guys. Thank you everyone for coming today. Thank you for learning a little bit more about Yotta Energy products and services. Like I said, we on the site here, you can go to our website, yottaenergy.com. If you are a current customer, have any support issues, support@yottaenergy.com or the phone number 833-MY-YOTA.
All right. Thanks, guys.
Thanks, everybody.